right, so next I'd like to try to get some timing information here about when in the evening you would expect to see each of these different phases. So with a full moon, the moon is over in this configuration. It's basically opposite to where the direction that you'd be looking to see the sun. And so if the Earth is rotating like this in a counterclockwise direction, and we're looking down on the Earth's north pole, we could just imagine a little person here standing on the surface of the Earth. Now that little person would actually be a giant if this were to scale. So we know that this is just like a little speck of dust in relation to how big the Earth is. But just so that you can see him, we'll put him there. And so if you're standing in this position then, and the sun is there, you'd be looking straight up, basically, or at least in the direction of the sun, to see the sun. When you look at this point, though, you're basically looking at a tangent. So you're looking along the horizon of the Earth to see the sun. And so this is the position, then, that would correspond to looking toward the west at sunset. And so if you get confused by this, you can just, if you have a globe, take the globe and then imagine that you're, say, in California, and you're looking this way toward the west. Okay, and so that would be off toward the Pacific Ocean. And you can see then that as the Earth turns this way, then you'd be moving out of view of the sun. And by the time you got to here, this would be midnight. So this would be something like 6 o'clock p.m. This would be maybe noon. This would be midnight. This would be 6 a.m. Not worrying about the seasons for this treatment of it. And so you can see then that if you were looking in the direction of a new moon, where the moon is kind of in line with the sun, the new moon would set right along with the sun. So it would be hard to see. Not only because you'd be looking pretty much in the same direction as the sun, but also because you are only seeing the shadowed side of the moon. You're not seeing the side of the moon that is being illuminated by the sun. In order to see that, you'd have to fly around in a rocket ship to the other side of the moon to be able to see it looking like a full moon. But from the Earth's point of view, you're just seeing that part of that half of the moon that's being illuminated, which in this case is none of it. Okay? And so that'd be hard to see then, and it would set right along with the sun. But each night after that, the moon moves in a direction that would look like an easterly direction to you. Moves by about 15 degrees each night from west to east. Okay, so the next night up, the moon would be here, and it would be just a little above the sun, and it would set something like maybe 45, 50 minutes after the sun. Okay. But as you go up to this position here in the waxing crescent, it would be, each night it would be another 15 degrees from west to east. That it would move up in the nighttime sky, and it would start to fill out as this happens. Until finally you get to the first quarter phase, and in the first quarter phase, the moon would be at its high point in the sky when the sun sets. Now, not necessarily straight overhead, but at least at the highest point that it gets to. So you'd be looking more up this way to see the moon, but then if you look this way toward the west, you'd be seeing the sun setting at that particular point. Okay, so that means that the moon isn't going to set until you get to midnight. Okay, so at midnight then, you're going to rotate first out of view of the sun. So the sun sets here. The sun is no longer visible because you'd have to look through the earth to see it. The earth's in the way, so you can't see it there. But then 6 hours later, you would get to a point where the moon would now be on the western horizon. It would be moving basically from east to west, and it would follow a similar path to the path that the sun took, although not quite the same path. And it would set at midnight. Just 6 hours after the sun. So each night then, the moon moves 15 degrees. That's about 50 minutes in time. In order for the moon to get back to its same point again. So 50 minutes in time before moon sets. For each day after the new moon. Okay, so it would set, the day after the new moon, it would set 50 minutes after the sun sets. Then it would be 100 minutes after 2 days, 150 minutes after 3 days, 4 days, 5, 6 days it would be 300 minutes, and then 7 days, that would correspond to roughly 6 hours, which would be the same thing as 7 times 50, 7 times 5 is 35, so that would be like 350 minutes. 360 minutes is 6 hours. Okay, so that gives you an idea of how much later the moon sets after the sun for each day following the new moon phase. And if you look at the same time each evening at the moon, you'd have to look another 15 degrees higher to see it at the same time the next night. Okay, so if you saw the moon, say, there one night, and you came back and you looked at it the next night at the same time, if you held your fist out at arm's length like this, the width of your fist would be about 15 degrees. And so that'd be how much higher the moon is in the direction that goes from west to east each night following the new moon phase. And it continues in that west to east path even past the first quarter. So eventually then we get to the waxing gibbous phase. So the waxing gibbous phase then, we'd see that set at about maybe 3 in the morning, because the tangent to this path at 3 in the morning would bring you to the waxing gibbous phase. So the waxing gibbous phase then would set around 3 in the morning. So that would be 9 hours after sunset. And so what about the full moon then? Well, the full moon, you'd see the full moon rise as the sun sets, and you'd see the full moon set as the sun rises. So if you look toward the west, you can see the sun set. But if we're in a full moon configuration, the full moon rises as the sun sets. And so this is why the full moon is up all night. And so I think this is one of the reasons why people say that people go crazy during a full moon. Because if you need a good night's sleep and you're getting this bright moon shining in and keeping you awake, then wouldn't that make you go crazy? But we're also tuned in to different cycles. And we know the grunion go out during a full moon cycle, and they get really excited. And I think a lot of other creatures do, because this is a time when you can hunt because you can see at night. And this is also a time when you can run if something is after you and trying to eat you. And so having extra light at night is kind of somehow incorporated into our biorhythms, and we seem to react to these cycles just instinctively because of different survival experiences that we've had in the past that relate to either being our survival being favored by a full moon or not favored if something else were trying to hunt us down. Okay, so the full moon then rises as the sun sets and is up all night, which means that the full moon sets as the sun rises. So you'd say, well, then that's really exciting if I'm an astronomer, because I can go out there and I can see that full moon all night long. But I don't really think of it that way so much, because it creates light pollution. And that light pollution makes it much harder to see other objects. And you go, well, at least I can see the moon. But no, not really, because when you're looking at the moon, it's too bright, for one thing. So you need a moon filter if you're looking through a telescope. And the other problem is that you don't have shadows on the craters when the light is coming straight down on the craters. So you don't have as good of definition for what you do see on the moon during a full moon. It's kind of the worst definition that you're going to get of the moon. So it's just kind of a big waste. Usually we don't have star nights that are anywhere near a full moon. A first quarter is a nice moon, or maybe a waxing crescent, because then there's very little light pollution, but then there's also a lot of shadows. So the craters that you can see have a lot of definition. So you can see a little piece of the moon in better detail, and you can still see the rest of the sky. Okay, so that means that the waxing gibbous would set 9 hours after sunset, but the full moon, if it sets as the sun rises, that would be essentially 12 hours after sunset. So this would be sunset, this would be sunrise, but this would be the point at which the full moon would set. And then during our waning phases, you can construct these as well. If you're here, say, at 9 o'clock a.m., you would see the waxing gibbous set. Then the last quarter would set around noon. And then the waning crescent would set around 3 in the afternoon. Walking along a tangent to the Earth's surface, you can see the waning crescent. So it'd be 3 o'clock in the afternoon. So you can see then that the moon is up just as often during the daytime as it is at night. And that is something that people usually don't notice because the sun is putting out so much more light that you can't really see the moon as well. But if you pay attention, you should be able to see the moon just as often during the daytime as you do at night. But if it's visible during the day, it may not be visible at night. So if you're, say, in a first quarter phase, that first quarter phase would set around midnight, and so if you're stuck out in the wilderness, your flashlight is just burned out, you may have a little bit of light from the moon until about midnight. Okay? So it actually is good to know, because that's like your universal flashlight, if it happens to be up at the right time, in order to give you visibility in the evening. Now what about rise times? Well, the rise times are going to be 12 hours, approximately 12 hours off from the set times. And so you can figure those out, and I'll leave that as an exercise for you to do. And I may ask for some detail about the timing of the rising and setting of the moon at different phases on our first quiz.